The next thing that is essentially important in terms of memory usage is LRU caches. So Yellowfin as an application has a couple of caches that we would say that we run to minimize the need to reload content from the Yellowfin repository and the source databases as in the cases as well. And that's all to basically make a fast and snappy experience for reporting, as you don't really want to be going back to the database each time when you're trying to do a little thing like load an ending page. You don't want to go back to the database to get config records or definitions if you're already having that sort of data ready by the time you come into Yellowfin. So in cases where it makes sense, we would actually have repository caches where we have a report definition cache, a dashboard cache, a thumbnail cache, and so on and so forth. But just to give you an idea of what each of these caches do, a report definition cache is a cache that stores the definitions for reports, including fields, formatting for a report, column formatting, and chart definitions as well. So when you create a chart, it saves the definition for that report in this cache. The dashboard cache saves content according to the dashboard usage. So, for example, definitions for dashboard layouts, attached reports, filters on the dashboard layer, that gets cached over here. The view cache essentially stores definitions for table joins, defined table fields and column formatting, and view level filters. The cache filter cache. These are basically filters that you use in reports that you could basically pre-prepare the filter values. So rather than having them show as user entry boxes or something that you go back to the database at runtime to search, you can essentially prepare filter values into a cache filter beforehand so that it's ready as a drop-down. So the values that you load will be cached in this area here. And the thumbnail and translation caches are basically for people who load quite a few images to represent things, will be saved there, and for translation for multi-language deployments. That's where we allow people to switch between languages very quickly, simply with a click of a button. Okay, and it basically retrieves the translations from this cache here. There are also other caches that apply at the source database level. So, for example, if I'm caching geometry shapes from a GIS server or a database that contains these shapes, then I can essentially cache these shapes into a geometry cache, and I can use them when I need rather than going back to the database each time. This is especially useful when I'm trying to drill from a summary report and trying to aggregate things by shape, which again at the database level is really hard to do or near impossible. But you can actually do that within Yellowfin because we've cached it already. You have some sort of a hierarchy relationship going on, which allows you to do this very, very quickly. It can aggregate against traditionally blob and clob fields very easily here as well. And a report data cache is essentially when you're trying to cache a report, where does the data go to? It goes into this area here. So these are the things that we have automatically in the application that takes care of a lot of the smooth experience that you get within Yellowfin, especially when you context switch between different pages. Now the key thing is, how do we actually modify these values when we need to? By default, all of the LRU caches have their own out-of-the-box values. All right, so by default, even if you don't actually specify them at the relevant file, the application will supply its own default value. However, you can actually override that with your own specific values for some very special scenarios. For example, if you know you're going to engage a lot in geospatial reports and you feel like the default shapes that are saved within the cache aren't actually enough, like you need to make a bigger max limit for that, then you can change that. So all these actions can be done within the Yellowfin web XML file. In the same file itself, how you actually introduce a value like that is via the init parent XML node code. So you can include this snippet over here as part of the web XML file, just include it at the bottom, and all you need to do is apply it to values, one being the actual parameter name, so the cache name, and the second being the parameter value, which is a cache value. Now, if you're wondering what's the actual official code to refer to these caches, you actually have that information at this link over here. So let's just go to that link that we specified on the storyboard slide and just have a look at what's actually available here. So we basically explain every single cache and how to refer to it by its name. So you can see geometry cache size. But what we actually expect as a value, so we're expecting a number, and what is the actual default value, which is 4,000. So what's it actually trying to say here is that the geometry cache caches the geometry user reports featuring maps, and we save by default 4,000 shapes in memory. If you feel like that isn't enough, you want to increase it to maybe 5,000 or 10,000, which again would need more memory, then you can easily change that within your XML file, and then it will be configured as that. And they can go down and do more things like, maybe I need to cache more dashboard definitions, or increase that from 1,000 definitions to maybe 2,000. Or I want to cache these things for a longer period of time. So by default, it caches it for a day, which is again by the measurement is by ms, so milliseconds. So that's by 86,400,000 milliseconds. But again, you can either decrease that or increase that at will. And then you will simply do that again in the web XML file. So coming back here, you would actually come into this web XML file and then introduce that init param XML node that I just showed you. We actually have some of these things already commented out, as you can see, but you can just simply uncomment that, and then that will come into play. So for example, I can actually introduce a report definition cache size, which again is a value of 1,000. I can maybe increase that to 2,000, uncomment this, save the file, and then when I restart Yellowfin, my cache size will be increased to that. Okay. Now, if you're wondering, now that I've done it, how do I actually confirm that this has been done within Yellowfin? Then you can actually refer to two areas. One being the console output when you start Yellowfin. So when you start Yellowfin, we actually record the startup parameters and all that into our log files and also to our output windows. So you can actually track that, or we can actually run the info cache JSP page. So for example, I can go to my Yellowfin instance as such and type something like info cache, and it actually tells me all the relevant values for the caches that are in play at Yellowfin. So really nifty, really good for telling me what's actually happening, and it actually tells me how much of it am I using, what's my oldest cache item, what's my newest cache item. So some really good info here that could feed into performance and capacity planning again. All right. So that's basically application caching. Now we can go back to the storyboard here, and then we're going to move on to content factors. So now that we've talked about memory usage, we've talked about application caching, then what are the other things that also come into play in terms of performance? And again, this is now content. So things that people have created within Yellowfin that comes into play. So let's go back into full screen mode. Okay, and these are the factors that come into play when you're thinking about performance and report rendering times. So just to give you an idea of what actually happens when you click on a report and you go, let's look at data for this particular area or this particular filter value. What actually happens when you do that? Yellowfin actually sends an optimized SQL query based on what you choose to the actual source database, and the source database does the work in retrieving that result set. Once it's finished, we'll send a result set back to Yellowfin, and it will render that on a browser, and there's about an additional 5 to 10% of time that we spend rendering maybe an additional chart or widgets or whatever you create at the multi-chart canvas, or whatever KPIs and targets that you set as part of your visualization layer. But in terms of the workload, the database actually does most of the work. Okay. There are, however, features that actually add to the work that an application server does. That's things that we do on our end. And these are basically contained within these dot points here. I run them through each point, okay, just explain what they are. The first thing is Crosstown Reports. So Crosstown Reports, if you don't know, are essentially pivot reports So you basically specify a dimensional category at not only the column value area, but also the row area as well, and then you specify one or more metrics, and they answer to both pivots, right? Which is why we call that pivot. What it actually does in the background is it takes a flat columnar result from the database and actually converts it into a matrix based on what you drop into the row and column area. Now, when there are many unique combinations, this could actually result in significant work that's done on the application server. For example, I could be pivoting on, maybe departments, and say I work for a very large company that has about, 10,000 departments, let's just say, as an example. Then you could be pivoting between quite a bit of things in this particular area here, which again could make the application server consume more resources. So if you have many cross-site reports, then maybe you need a bit more resources in terms of memory and CPU to support that sort of reporting suite. Section reports, again, a similar process for grouping data sets into sections. What this does here is it actually allows the user to break a real table into multiple versions of it based on a column that you set as a section. So for example, over here, I've basically put the gender as a section column, and rather than showing it as one table, Yellowfin is breaking it up into the section column of female and male, and it's giving me the relevant values for that. Now, if I break it up to something that's a bit more distinct, like say last name for every employee in a company, so you could very well end up with many, many tables in a particular report, which again would involve looping through and creating new tables for each of the section columns, which again would consume resources as well.